Okay, so right now we're going to be working on the final exam problem from the spring 2017 final exam. This is question 1, and we're looking for the integral of 21x minus 16 all over x squared plus 9 times x plus 4. It's nicely factored out for us already, so we don't have to think about it too much. We've got a function in the denominator, which tells me that I need to be thinking about partial fractions so that I can actually integrate this. Okay, so the first thing I'm going to do is I'm going to write this down here, 21x minus 16 all over x squared plus 9 times x plus 4. And I have to think about how I'm going to break this apart and what I'm going to be setting this up as. And it doesn't matter the order of these way that they're presented here. Now, I've got this x plus 4. This is factorable. The solution to this, I set this equal to 0. I can solve and actually get x equals minus 4 as a solution. X squared plus 9 is an unfactorable quadratic, which means that I need to be thinking about another way to work it. It is not equal to x plus 3x minus 3. Okay, that's x squared minus 9. It's not equal to x plus 3 quantity squared. These are all things that I've seen when people are working through partial fractions. So please make sure that when you're actually working through these and you think you've got it all factored out, that you actually FOIL it out to see that you've gotten back the quadratic that you started with. If you get something different, that might be a clue that this is unfactorable. Okay. All right, so let's think about it. I'm going to start off with this one. That means I just need, because it's factorable, I just need a single variable as its numerator. This one here, because it's unfactorable, I'm going to need a bx plus c as its numerator. Okay, that's our form for partial fractions for being able to work it through. Okay, so now the first way, my goal is to be able to solve for a, b, and c. And the first thing that I have to do when I do that is multiply both sides by the denominator over here. So x squared plus 9 x plus 4. And then what happens, I'll rewrite this for 21x minus 16 equals a times x plus 4 is cancel. I'm left with a times x squared plus 9 plus the x plus c. The x squared plus 9's cancel, and this gets multiplied by x plus 4. Okay. So now, how we need to think about that is, okay, we've got some low-hanging fruit here. We said that this is solvable. This is x equals minus 4 is our solution here. So that low-hanging fruit, if I set x equals minus 4, everywhere I see a minus 4, okay, then I'm going to be able, everywhere I see an x, I'm going to plug in a minus 4. So I have 21 times minus 4. Minus 16 equals a times minus 4. Watch out for this, minus 4 quantity squared plus 9. Be very careful, your calculator may actually do a stupid thing. When I do this on my calculator, if I do minus 4 squared without the parentheses, it's going to give me minus 16, which is wrong. Minus 4 quantity squared. Okay, plus, I don't even have to do anything else here. If I plug in a minus 4, this thing's going to drop out to 0. 0 times that makes that whole thing 0. Okay, so now let's add everything together. Okay, so now, oops, if I look at it, 21 times minus 4 is equal to minus 84. Minus 84 minus 16 gives me minus 100. Equals, right, this is a times, this is 16 plus 9, that gives us 25. So minus 100 equals a times 25. Divide both sides by 25. I get a equals minus 4. Okay, that minus 4 is not the same thing as that minus 4. This is just what our coefficient is equal to. Okay. Well, that's good. So now I'm going to plug things back in. X minus 16 equals. Now I can take this a and I can plug it into here. Minus 4 x squared plus 9 plus bx plus c x plus 4. Now I need to do something different to solve for b and c. And what I'm going to do for that is I'm going to group things by like terms, like by coefficients, and then set the coefficients on each side of the equation equal to each other. But first, let's multiply and distribute everything through so that we can actually start to think about things like that. So minus 4 times x squared gives you minus 4 x squared. Minus 4 times 9 gives you minus 36. Plus, let's FOIL this out. Bx times x, bx squared. Bx times 4, 4bx. C times x, and c times 4. Okay. Okay, so let's think about our coefficients. So I've got an x squared term and an x squared term here. So I'm going to factor out the x squares, and I'm going to get I'm going to get b minus 4 as my coefficients for x squared. I've got x terms here, so I'm going to factor out the x, and here I have 4b plus c left over. Okay. Plus, let's group our coefficient terms together. C4 minus 36. Okay. Now this is equal to 0x squared plus 21x minus 16. Okay, so I'm going to, my coefficient for my x squared term is 0. So I'm going to go 0 equals b minus 4. That's my first equation. This is a little divider. 21 is the coefficient for my x term, 4b plus c. And then my constant terms, minus 16 equals c4 minus 36. Okay. So I've got 3 equations and 2 unknowns. This one has 2 variables in it. This one has 1 variable, that one has 1 variable. So I'm going to focus on the ones that have only 1 variable. It's going to help me. Add 4 to both sides. 4 equals b. Now I've solved for b. Okay, look at what's happening here. I'm going to add 36 to both sides. 36 minus 16 is 20, equals 4 times c divided by 4. C equals 5. Let's just confirm. I'll plug it back into here. So 21 equals 4 times 4 plus 5. 16 plus 5 equals 21. So 21 equals 21. Good cross-check to make sure that we didn't make an algebraic mistake. All right. So remember, the whole point about our partial fractions is to be able to take this, find our coefficients for a, b, and c, so that then I can integrate them like that. All right. So I'm going to start. I'm going to rewrite my original integral. 21x minus 16 all over x squared plus 9 x plus 4 dx was equal to, this was a over x plus 4. A was equal to minus 4 x plus 4 dx plus bx plus c. B was equal to 4. C was equal to 5. And that's a dx. Okay. So let's deal with this one first. So I'm going to factor out, got this minus 4 integral 1 over x plus 4 dx. I can think about u substitution. My u is equal to x plus 4. My du is equal to dx. I'm going to take the integral of 1 over u du, which is going to give me the natural log. So I've got minus 4 over 4. Natural log, don't forget your absolute value of x plus 4. Plus, let's do with this one now here. So I've got 2 terms here and 1 denominator. I'm going to take this denominator and split it up. So I've got 2 separate integrals I'm going to work with. 4x x squared plus 9 dx plus integral of 5 x squared plus 9 dx. Let's do this one first. This is, I've got an x in the numerator and an x squared in the denominator, right? And just x squared plus 9. So x is the derivative of x squared. So I can think about u substitution. Squared plus 9, right? Du is equal to 2x dx. So if I divide both sides by 2, I've got du over 2 equals x dx. And you can think about, maybe I'm just going to bring the 4 outside of here. So this is going to become plus 4 integral of 1 over u du over 2. So I bring out the 1/2, right? So this becomes plus 2 natural log. It would be natural log of u, but I'm going to substitute my x squared plus 9 back in there. Okay. Let's do with this one here. Okay, so 4 divided by 2 gives me 2 here. That's where that comes from. So this, I can bring my 5 out, and I've got 1 over x squared plus 9 dx. Okay, this is our trig. Okay, this is an inverse tangent function, which x squared plus a squared is our format. Okay, so this is always how we integrate that is 1 over a inverse tangent of x over a. Okay, and in this case, our a squared is equal to 9, which makes our a equal to 3. Okay, so plus, I've got the 5 from before, 1 over a, okay, which is 5 over 3, where that comes from, inverse tangent of x over a, and I'm going to add in my plus c. Now let's not forget our first term that we integrated before, so minus 4 natural log of x plus 4. And so our total answer then is this right here. minus 4 natural log of x plus 4, absolute value, plus 2 natural log of x squared plus 9, plus 5/3 inverse tangent of x over 3, and then don't forget your plus c because it's an indefinite integral.